Good afternoon to everybody. This is our next video on the 20-time rant experiment, and we're going to be focusing on step 6, data analysis. There is already a rubric up online. Once again, it is called 20-time rant experiment, step 6, data analysis. So last week and the last couple of weeks you've been doing is collecting the data, making a chart in either Google Sheets or in Excel, and we just have pure data, no graphs, no analysis. Now the next 2 weeks, that's what we're going to be focusing on, putting this data into logical graphs and analyzing it in appropriate ways. First off, I'll get the easy ones out of the way in the bottom here. Properly use technology, tools, and data analysis. So did you use technology, as in did you use a spreadsheet? Did you use Google Sheets to actually make your graphs? Or did you kind of do it, but it doesn't make sense? Now, if you do not use technology at all, if you just hand in a graph that it's on paper, it's not going to count and you're not going to get any points. So you got to use some type of spreadsheet to make your graphs. Next, productivity. Are you working passionately over the next 2 weeks? Finally, professionalism, being on time. The project is handed in at the start of class. Let's talk about the meat of this, and that's taking the data you have and analyzing it. First, it says identify and address limitations of data analysis. So we have our data, but what are some limitations that we're like, oh, we can't really analyze it to 100% because of this? Now, example of having limitation of data analysis, if let's say a person decided, hey, they were going to look at a YouTube video and they were going to see how many hits they had or views they had over a 3-week span, and for whatever reason they didn't put up their video until 3 days before the data was due. That's a limitation. When you only have 3 days of data on a YouTube presentation or project, that's going to be very limited. Another limitation or data interpretation that might be hard is when you're working with qualitative data, as in multiple groups have done data where it's opinion based, it's at how you feel, and for those people that have done that, they did put it on a scale of 1 to 10, how do you feel, but at the same time you're limited to how that person felt, which is emotions. So anytime there's emotions in collecting data that is not just strictly counting, there's going to be a limit on how do they feel that day, and there's so many other confounding variables that deal with, all right, they feel this way, but is it because of my experiment or is it because something else that happened throughout the day? So that would definitely be something that would be affecting your analysis. Is either through emotion or not collecting enough data, measurement error, maybe possibly you did the test one day with a certain type of measurement day. Let's say you weighted paper for recycling. You weighed it on a scale on Monday, then on Wednesday when you weighed new paper, you use a different scale. Right there, you're going to have measurement error. Using 2 different scales is never a good thing. So that's limitations on data. Data analysis tools. Are you able to determine appropriate data analysis tools, technology, statistics, graphing in an organized manner? So let's go over to a spreadsheet that somebody has created already. Now right here we do have data, and we do have an analysis, which is a graph. At this point, we do have a graph, but it is not organized at all. We've got data over here. We've got different graphs all over the place. To make it organized, I would take this, copy it from our Google Sheets, and post it into a Word document or a Google Doc to explain it. So anytime you're making a graph or a pie chart, take this, don't leave it on a Google Sheet, copy and paste it into a Google Doc so it's easier to see. and that'll make it more organized. Having graphs on top of each other, over each other, obviously not organized. So it's got to be clean, it's got to be neat to get the full points. So that's what it means in an organized manner. Then finally, down here, we're going to have multiple examples of this, but proper data analysis using scientific terms and includes justification of data analysis. So to get top 4 points, you have valid and reliable analysis of data. You use scientific terms for analysis. And the big thing is there are no opinions included in the analysis phase. So let's go down here and show you an example. So before we get to this example, I've written up a small description of what analysis is. The section is an explanation of what happened during your experiment. It has to include graphs constructed from your data tables collected during the experiment. No opinions are to be included in this section, just facts from your experiment and the research from step 2 of the scientific method. Opinions are going to be, though, necessary in the going beyond section. Analysis has to be very detailed and have no fluff. Everything that you observe, made, or collected needs to be explained, including errors of limitations. If enough data was collected, the analysis should be at least one double-spaced page in Times New Roman at 12-point font in length. So if you did the experiment right, you should easily be able to analyze and have enough analysis to fill up one page. If you take a paragraph to analyze everything you've done, you don't have enough data or you did not explain it enough. Now, how should it be written? Well, if in the analysis section it's completely correct there. A reader should not have any questions about why certain data was collected or what the data means. So if a third party comes, they read your research, they read your analysis, they shouldn't be stumped or questioning how did they get that, why did they get that. And with that, to get that reader to understand everything, you need to include the following: specific numerical results, specific dates if dates are included. It has to be unbiased, which means you don't include any opinions. Use of anonymous name references. So if you have a bunch of names, especially if they're under the age of 18, do not use their real name. Just put participant 1 or subject 1. Do not use their official names. They can be on the data for step 5, but when you do the analysis, you have to take out their names and put participant 1, 2, and so on. And finally, there's got to be some connection to the information research in step 2 of the research. So I made some examples here. A quality example reads, based on the data, there is a 20% increase in a participant 1's free throw shooting average. The increase happened over a 3-week span, with all the participants shooting 3 times a week. Very detailed. We've got specific data. We've got a span of time. We have participant 1, and we tell how much it is. It's unbiased, has nothing to do with opinions, it's all right there. A poor example. It was cool to see Jin Lee's shooting her free throws better over the couple times she tried. I knew she was going to do this, or I knew she was going to do this good. There's no descriptions, it's very vague. You're using cool, you're using I knew this was going to be good. So opinion, non-factual, it's not going to get you anywhere. It's right up here. It's got to be percentages, numbers, very analytical, and no opinions. When you are constructing the graphs from the charts and you are having to analyze them, please watch the next video. It's going to be describing how to make a proper graph and how to analyze an example from that graph. So once again, this is step 6, data analysis, and we're taking that data, putting it into a graph, explaining the graph and the data, and also making sure what were our limitations in that. So have a great day, and that is step 6, data analysis.